This video is going to show you how to use the Beckman to do a kinetic scan, meaning you're measuring a reaction rate. I'm going to go to the main menu. Exit to main menu? Yes. Here I've got things that you have used before, like the fixed wavelength and the scan lambda, meaning a wavelength scan. The one you want to use this time is the kinetic time. So it says kinetic time. I'm going to click that button. I have options. Total time. I'm going to set this to 1 minute. Interval. How often do I want to read a sample? How often do I want to take a measurement, really? It says between 5 and 60 seconds. I'll put it to 5. That's the shortest time interval I can do on the Beckman. Go to lambda. What wavelength? I'll tell it I want to measure at 400 nanometers. And that's it. 1 minute, 5-second intervals. 400 nanometers. I can see up here on the screen it says 400 nanometers. Alright, I'm going to click more, but there's nothing there of interest. Alright, so I'm ready. I clicked exit. Now I'm here. It says blank required. So here's my cuvette. I'll pop my cuvette in the machine. And I'll say blank. It takes a measurement. It takes very little time to take one measurement. And now it says ready to start. I'm going to say start. The bottom axis is time. It gives me a little countdown saying next point in 4, 3, 2, 1, beep. It just took a time point. 2, 1, beep. It took another measurement. On the screen, so far I'm seeing a flat line. That's because I don't really have any reaction going here. I just put distilled water in the cuvette, so this should be a flat line. No change in absorbance over the 1 minute of time. I will let it complete its 1 minute run, and then we'll see what the graph looks like. It says storing to file number 2. And here's the graph. I think you can see it in the video. It's a little wiggly, but the scale here says 0.001 is the top and negative 0.001 is the bottom. So this is very, very flat, and that's good. That's the way it should be if I don't have a reaction running. Once I'm done, I just take the cuvette out and pass it on to the next person, or if I need to make an adjustment in the cuvette itself, I would make the adjustment, pop it back in. If I pop it back in, I don't need to re-baseline. If it's the same baseline I would use, I just click start. And then it's ready to make another kinetics measurement over another minute of time. Now I'm going to show you how you get linear data. I think you can see on the screen, here's some kinetic data, time on the x-axis, but it's not a straight line. There is a straight line portion toward the beginning, but then it gets a noticeable curve. So I'm going to set my cursors to the interval in which there is a linear rate. So the cursor buttons right now are moving both sets of cursors, both the beginning and the end. So I want to say my mode left, meaning I'm moving only the left hand time marker, and now I'm going to move the left hand time marker to the beginning. Okay, so that's near the beginning. How about right there? So that's at 0.08 minutes. That's 1/12 of a minute. That's 5 seconds. So it's starting at t equals 5 seconds. Now I'm going to go back. This is a little tedious. So if you didn't see what I did, I pressed the more button. Now I'm going to mode right. Now I'm just going to move this right hand time marker over till I get to a linear rate. So cursor, move that right hand cursor to the left. I'm just holding down the button now and it's going jump, 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 jump. Okay, so that I think is a pretty good rate. That's between 5 seconds and 45 seconds. To me, that looks like it is a linear portion of the graph. So that I can then print as a graph. Hold on a second. I've moved them so that I've got a linear portion. Now I'll go back to mode and say rate. Once I hit mode rate, a number appears on the bottom that expresses the change in absorbance per minute. And it gives me an r-squared value saying how linear is this data. And the closer to 1 the r-squared value is, the more linear the data is. So this is 0.999. I can't do better than that. And so this is what I want to then print. Print the graph. It's going to print out with my rate on the display. It's going to print out basically what I see on the screen. And that's going to be excellent data. Alright, so here's my hard copy. You can see linear portion is bracketed by the two cursors. Rate is shown on the screen on the printout. 0.0959 absorbance units per minute. That's my rate. On the evolution, when you want to do a kinetics run, measuring the rate of reaction, the icon you want is the one that shows the axes and then a sloping line. You should think sloping line sounds like a rate. So I click on that. Then I have to make some choices. So I'm going to, on the window, choose my method. Method comes up. What I need to choose, wavelength. So I'm going to choose 235 nanometers. Okay. I need to choose the duration of time. I'm going to go for 2 minutes. So right now it's set for select units, seconds, and milliseconds. I don't want that. I want minutes and seconds. So I'm going to go for 2 minutes and no seconds. Okay. Interval. Right now it's set to measure every 130 milliseconds. That seems excessively fast. I'll do 2 seconds every 2 seconds. Alright, so that's going to be 60 data points. And it actually says 61 because it counts the initial 0 point, t equals 0 point. So then 2 minutes total time, 2 second intervals, only got one sample, 235 nanometers. It looks like it's ready to go. So I've set up the method. Then to run the actual reaction, I'm going to use my black cuvette and I'm going to put it in the machine. So before I actually measure a rate, I need to baseline it. So into the machine it's going to go. Into the machine it goes. Pop. Then on my computer screen, going to click on the standard baseline icon. It says put your reference cell in the machine and press proceed. Alright, I say proceed. My baseline has in it the buffer and the ampicillin. Now I'm going to add my enzyme. So I'm using my pipetter to measure a bit of enzyme. This is the periplasmic extract. I'm going to put that in the cuvette. Before I start that though, I should click on the running man and tell it I'm ready to make a sample measurement. This is going to be sample, I'm just going to call it sample 001. Okay. As soon as I click proceed, it's going to start collecting data. So I need some teamwork now. I need to do the right thing on this side, and then I need to click the right thing on the computer. So watch what I do here. Cuvette with lid. So the lid fits well. Pipette with enzyme. Injecting into the solution. 1, 2, 3. In the machine. Pop. Hit proceed. Pop. It starts measuring data. I'll go to the rate graph there. It's collecting data. And it's going to collect data for 2 minutes, which is not that exciting, so I'm going to come back. Alright, here's data I collected from that experiment. You can see sloping downward, but then it bottoms out. So I want to measure the rate in this portion here, in the beginning, when it is linear. So in order to get the computer to tell me that rate, I go up here to Math. So there is a button called Math. I click on Math. I click on Rate Calculations. That should make sense to you. I want a rate. I want a linear search. And then I need to tell it what I'm actually looking for. So I need to pull over my data. This is data sample 001, that's what I called it. I pull it over. And then I tell it what section I want to look for a linear rate. So this one I don't have a long linear rate search. So I'm going to just do 4 second actually. So clear that. 0 minutes and 4 seconds. Okay. And I'm going to say start time 0 and end time 30 seconds. So somewhere in the 30 seconds, first 30 seconds give me a linear rate, and it gave me a linear rate between 0 and 4 seconds right here in the very beginning. So that's how you do it. You need to select a time interval in which you want it to search. So this time I said between 0 and 30 seconds. In this case I told it look for a 4 second. Give me the rate over 4 seconds. Those of you who are in calculus know that's an average rate over the 4 seconds. But on my screen I say that's pretty good. The slope of the average line is very close to what I think the rate of the reaction actually is. So I say close that, and now I go to my results table, and on my results table I got 2 pieces of data here. I got best fit number 1, which is garbage, and I've got search 1, that's my linear search, and that tells me the rate, which was negative 1.54 absorbance units per minute. That's a rate.